Hello everyone, today teacher Sani is going to explain a question that combines shaping techniques. Alright, when we solve problems, the first step is to carefully read the question. I explained this in the previous question. Carefully reading the question is a very important step and method. If you read the question well, more than half the problem is solved. If you don't read it well, then there's no way to solve the problem. Alright, let's look at the question. A has 64 lessons, B has 24 lessons, and each day they both take 2 subjects. After a certain number of days, A becomes 5 times B. Okay, let's use the method of drawing diagrams for ratio and multiplication problems. So after a certain number of days, the final result is that A is 5 times B. What does this tell us? This tells us B has fewer lessons than A. If we use triangles to represent the number of lessons for B, of course you could also use line segments, but here we'll use this. Shape, a geometric figure to visually represent it. So for example, if A is 5 times B, that means we need to draw 5 distinct triangles. Alright, so we need to draw 5 triangles to represent that it is 5 times B. Okay, now, from carefully analyzing the problem, we clearly notice an extremely important key point. A consistently eats 2 delicious candies every single day, and B also consistently eats 2 delicious candies every single day. In other words, each and every day, they both eat 2 candies. So the number of candies left decreases by 2 each day, right? So in this case, when both increase or decrease by the same amount, in terms of this particular concept, their difference truly remains unchanged. That is to say, however many candies they initially differ by at the very beginning, the total number of candies they differ by at the very end will be exactly the same. Here, let me explain this a bit more clearly. For example, a minus b equals a difference, right? This fundamental mathematical operation yields a difference, which is the result of this calculation. So if A increases by 2 units, and at the same time B also increases by 2 units simultaneously, consider a scenario where then the difference between them remains the same, it doesn't change. Their difference stays the same. Okay, similarly, if A decreases by 2, and B also decreases by 2, then their difference also remains unchanged. It also stays the same. This is called the difference remains unchanged when both increase or decrease by the same amount. So it's the same situation here. The difference is right here. 5 triangles minus 1 triangle leaves a difference of 4 triangles. That is 64 minus 24 gives a difference of 40. So this difference, this 40, remains unchanged from the beginning to the end. So from this, we can already see it clearly. These 40 delicious candies correspond directly to 4 distinct triangles, which explicitly means that these 4 triangles, when taken together, add up to a total of 40 candies. In other words, it's abundantly clear that one single triangle precisely represents 10 individual candies. Right? So, in the problem, this is equal to the number of candies B has left in the end. Then, a few days later, B has 10 candies left. So B also has 24 candies. Isn't that right? In the end, he only has 10 candies left. So how many did he use? That means he used 24 minus 10 candies. He ate them, right? He certainly ate them. He consumed these 10, he ate this many candies. 20 minus 10, right? So after a few days have passed, he has already eaten 14 delicious candies. If he eats 2 candies a day, then 14 divided by 2 is exactly 7 days. So, after 7 days, A has 5 times as many as B. After 7 full days, A is 5 times as many as B. Did you fully understand it? If you did, please kindly give Teacher Sunny a like, follow, and share this valuable information with others.